Okay, problems number 5 and 6 coming at you. Let's see. Let's get over here to this guy. Okay, problem 5 and 6. I've got a couple of coordinates in the different circumstances. These are in rectangular moving to polar. These two are in polar moving to rectangular. So the first thing you want to remember is that when you move from rectangular to polar, the first thing we want to do is we want to find that radius. And so Pythagorean theorem would say that 4 squared is 16, 2 squared is 4, which makes this root 20. Now, we should reduce that and make it 2 roots of 5, but that would be my radius. And I know that you guys just finished the imaginary portion. These are not imaginary numbers. There's no I in this. It's literally just -4, 2. Now, again, this is a nice problem because it's not unit circle, so I'm just going to go ahead and allow my calculator to do some of the work for me. I prefer things in radians, but if you like degrees, you can get that answer. And I'm going to ask my calculator to go to the angle 6, and I'm going to tell it that I had -4 and 2, and it's going to tell me that my angle is 2.678 radians. And you know that my answer is in radians because I didn't put a degree symbol. Now, in part B, I went over 7 roots of 3, and I went down 7. Well, I hope that that actually looks pretty obvious to you that I'm using one of those special right triangles. That's 14 would be my radius. And I notice that the sign is really nice. You see how the sign of theta opposite over hypotenuse is -1/2? Well, I know that the sign is 1/2 anytime there's a pi/6 involved. So I'm looking for an angle pi/6, but I'm going to choose an angle that is a -pi/6 because it rotated down into that quadrant. Now, that's how you go from rectangular to polar. Now, when you go the other direction, we have a simple formula. Remember, x is r cosine theta. X is r 14 cosine theta. And I know that the cosine of any kind of pi/6 is √3/2, and 7 pi/6 is in the third quadrant where it was negative. So my x value became 7 roots of 3 because 2 goes into 14 7 times. Similarly, y is r sine theta. And I know that the sine of any kind of pi/6 is 1/2, and the sine of 7 pi/6 in the third quadrant would be negative. Remember, third quadrant, the sign is negative. And so my coordinate says x is 7 roots of 3 and y is 7. That was pretty easy. And then last but not least on part 5 is if my r is 13 and my theta is 137 degrees, and my r is 13 and my theta is 137 degrees, all I have to do is grab my calculator, choose to go into degree mode, which is there, 13 cosine of 137. My x value is -9.508, and my y value, with the sign instead, is 8.866. And so I just get to use my calculator on that problem because there's nothing more that I can do. Now, when you go into number 6, instead of converting coordinates back and forth, it's full-blown equations. So I'm going to choose to do number 6 in this video and 7 in a different video, even though they overlap. But what I know is that x is r cosine theta. I know that y is r sine theta. So all I have to do to get r by itself is factor out that r. And so if I wanted to get r by itself, just divide. I'm done. Done. Awesome. Now, letter B, that looks a little bit tricky, and I kind of did that on purpose. X squared plus y squared is r squared. X is r cosine theta. Y is r sine theta. That looks kind of bad, but I'm going to move everything to the same side together because I like things to be set equal to 0 if I can. So Because it's all equal to 0 and these all have an r in common, I could factor that out just a little bit. Let's pull an r out of each piece. Now that means the only way that this product can be 0 is if r itself is 0, but I don't think this is the equation of a dot at the origin. This is silly. Or if r balances these out to cancel them out. So r would need to be a positive 4 cosine and a negative sine, and I'm done. That's kind of a weird one. And last but not least, this one is, x would be r squared cosine squared theta. Y squared would be r squared sine squared theta. Now in this case, I'm going to factor out an r squared, and I got cosine squared minus sine squared. And I don't think we've ever done one of these in class like this, but if I divide, I'm actually kind of done right now. And this may feel awkward to you, but I kind of have r isolated. And so that is the end of that particular problem. And so I will see you in the next video with problems 7 and 8.